Welcome back to 3 Inquisitive Kids. In this video, we will be using the perfect square formula, and this is part 2 about the application of this perfect square formula. Our course outline for this unit tells us that we first learned about the laws of exponents, and then we learned about the scientific notation. Then we learned about multiplying and dividing polynomials and monomials. In these 3 lessons, we've been learning about the square difference formula and the perfect square formula. And these 2 formulas are very important when calculating polynomials and monomials. Our learning goals for today is to dig deeper into the perfect square formula and be able to flexibly apply it onto calculations and problems. This is the perfect square formula. The sum of a plus b squared equals a squared plus 2ab plus b squared, and the difference of a and b squared equals a squared minus 2ab plus b squared. I want you to ask yourself, what terms do the a and the b correspond on to my problem? And can I reverse this formula when calculating? Because sometimes when you are calculating an expression, you have to figure out which term is equal to a in this case and which term is equal to b. And in some problems, you actually don't go from a plus b squared to a squared plus 2ab plus b squared. You actually have to reverse it. So you go from a squared plus 2ab plus b squared back to a plus b squared. And that's going to make simplifying easier. How can you calculate 102 squared and 99 squared more efficiently? Think about using the perfect square formula. We know that 102 squared is the same thing as 100 plus 2 squared. So when we apply the perfect square formula to it, we get 10,000 plus 400 plus 4. And that's very easy to add together. We get 10,404. For 99, we can rewrite it as 100 minus 1. And all we have to do in the end is 10,000 minus 200 plus 1, which is 9,801. Now, I want you to think about what would happen if you just wrote out 102 times 102 and started multiplying. Using the perfect square formula in this case is much more efficient. I want you to use the square difference formula to simplify this expression. Now we're using the square difference formula. So our first step is to use brackets and parentheses to group certain terms together. You can see that we've grouped this 2y minus 3 in both polynomials together, so we can look at them as a whole. We apply the square difference formula to get x squared minus 2y minus 3 squared, and then we use the perfect square formula. X squared minus parentheses 4y squared minus 12y plus 9. Remember, we still have the parentheses here. And now, after we use a perfect square formula, we can distribute this negative 1 into the parentheses. We get x squared minus 4y squared plus 12y minus 9. I want you to pay attention to the signs in parentheses. Sometimes you can group multiple terms together and look at them as a whole to make calculating easier. Here we have a plus b plus c squared. Again, in our formulas, we've been dealing with only 2 terms. Now, in order to get 2 terms, we have to group some terms together. You can see that in this case, they've grouped the a and the b together. So now, using the perfect square formula, we know that it's equal to a plus b squared plus 2 times the sum of a and b times c plus c squared. And for this first part of our polynomial, we have to use the perfect square formula again. We get a squared plus 2ab plus b squared plus 2ac plus 2bc plus c squared. This is our answer. Example 2. Simplify this expression. Our solution is to first use the commutative property of multiplication to swap the order of these binomials around. We can first just focus on this first part of the calculation. X minus 2y times x plus 2y. We can use the square difference formula for this. After multiplying this, we would get x squared minus 4y squared. So that's our parentheses. But we still have this parentheses to multiply to it. So that's technically the same thing as just x squared minus 4y squared squared. And then we apply the perfect square formula, which gives us x to the 4th power minus 8 x squared, y squared plus 16y to the 4th power. apply formulas you know to complicated problems and then break things down bit by bit. So you can see that we usually need to use the square difference formula once and the perfect square formula once. Class summary. Today we learned about using the perfect square formula. The formula is a plus or minus b squared equals a squared plus or minus 2ab plus b squared. And I want you to remember that you might not be able to apply the formula directly. Think about what you would need to do first. You can try simplifying a little bit and then rearrange the terms and maybe look at some terms as a whole. And we need to understand the differences between the perfect square formula and the square difference formula.